Hello everyone, this is RVS Dinesh, roll number 19EC01002. Today we will be discussing about MATLAB GUI and waveform generation. First one, we will discuss waveform generation. In the waveform generation, firstly we will discuss about generating elementary signals in continuous and discrete time intervals. The first function is unit step function. You can see the unit step function is nothing but when t is less than 0, it gives value of 0, and t is greater than 0, and it gives 1 value as 1. When we run the program, we get the unit step function in continuous time interval, and this is the unit step function in discrete time interval. Moving on to the next one, we will see rectangular pulse function. This function, I did the same thing as unit step function. When we run this code, it displays rectangular pulse function in continuous time interval and discrete time interval. The next, we will see signum function. I think all of you know about signum function. It is divided into three parts. When we run the code, we display signum function. The signum function is -1 for all the negative part of t, and 0 for 0, and 1 for all the positive part. And this is the signum function in discrete time interval. For all the functions, I have taken the sampling space as 1. The fourth one is the ramp function. The ramp function, I can do it by multiplying unit step function to the interval. The ramp function, as you can see, the ramp function is 0 for t less than 0, and straight line with a slope 1 when t greater than 0. This is the ramp function in discrete time interval. Now coming to the fifth part, it is sinusoidal function. I have taken a simple sinusoidal function which is 2 into cos t, and when we run the code, it displays a sinusoidal function in continuous time interval and discrete time interval. And the next one is exponential functions. This is of two parts: rising exponential function and decaying exponential function. When we run the code, this is it contains two parts: rising exponential in continuous and rising exponential in discrete. This is decaying exponential in continuous and decaying exponential in discrete. Moving on to the next part, we have sinusoidal function in exponential. When we run the code, it is a 3D plot. As you can see, the blue color displays continuous time interval, and red color displays discrete time interval. Now moving on, we will see casual exponential function. When we run the code, it displays casual exponential function in continuous time interval and casual exponential function in discrete time interval. Casual exponential function is nothing but multiplying an exponential function with a unit step. As you can see, I have multiplied exponential of minus t star dot in unit into unit step. The next part is impulse function. When we run the code, this is an impulse function from time interval 0 to t in continuous time interval, and this is an impulse function in discrete time interval. Now moving on to the second part of the generating basic waveforms. In second part, we will be dealing with generating periodic signals. The first one is periodic sawtooth waveform in continuous and discrete. Sawtooth is a built-in function in MATLAB in signal processing toolbox. When we run the code, this is a sawtooth waveform with time period 3, and this is a sawtooth waveform in discrete time interval. Moving on to the second part, we will be generating a periodic pulse waveform with a period of 4 seconds and a pulse width of 1 second. When we run the code, this is a periodic pulse wave of time period 4 seconds and a pulse width of 1 second. It is in continuous time interval. Moving on, this is the periodic square waveform with fundamental period of 2 seconds. Now running it, this is the square waveform. And next one is triangular waveform with fundamental period of t. I have used the same sawtooth function but an extra value of 0.5, which makes it triangular. As you can see, this is a periodic triangular waveform with fundamental period of 3 seconds. And then moving on, this is the periodic sinusoidal waveform with the fundamental period of 1 second. When running it, this is a sinusoidal waveform with fundamental period of 1 millisecond. And by coming to the third part of the generating waveforms, we are generating three sinusoidal waveforms of frequencies 100 hertz, 250 hertz, and 500 hertz, and amplitudes of 1, 0.75, and zero point 0.5, and we are adding to form a single output. As you can see, I have wrote the equations of x1, x2, x3, and I have add, and by running it, we will get the graphs of x1 of t and x2 of t and x3 of t, and the combined graph by adding the three of them. Now the next part is taking two sinusoidal waveforms with frequencies 125 Hz and 1000 Hz and amplitudes of 1 and 0.5, and now we are multiplying those two functions. I have taken these two and I have written y equal to x1 dot star x2. Dot star operator will be used in multiplying component wise. When we run the code, this is the graph of x1 of t and this is the graph of x2 of t. This is the graph obtained by multiplying the both x1 and x2 of t. Now we will be discussing about MATLAB GUI. GUI stands for Graphical User Interface. I have done GUI in Guide. You can also do it in App Maker. And now opening this is the basic layout of the file I have did. I have done a simple GUI. You can also do it by adding the tools provided here. Now you can view the settings by using property inspector, and you can change them if you like to. And now to view the code, I am making a callback. This is the code I have written. This one helps us to get the values from the switch. In the switch I have written 24 cases. As you can see, these 24 cases constitutes of the codes which I have written in the first part and first A and 1B. As you can see, this is the unit step function graph and continuous and discrete and so on up to case 24. Now when we run the code, the GUI displays. As you can see, the first one is the unit step function and rectangular pulse function, and then the signal function in discrete time interval, also sinusoidal function in continuous time interval, decaying exponential function in discrete time interval. Here the extension CT_CT represents continuous time interval and _DT represents discrete time interval. As you can see, the CT represents sawtooth waveform in continuous time interval and DT represents in discrete time interval. The user can choose the graph and click on the pop-up menu and choose the required graph. Thank you for listening.